This is just a quick rundown for the 8th grade dilations with perimeter and area. This is something that we did a lot of this in class together, but just in case anybody wasn't here or needs the extra notes for it. So number 1 says the rectangle ABCD is dilated to create rectangle ABCD prime. On each one of these, we're supposed to be finding the scale factor on all of these. On every one of these, we're going to be doing new divided by old in order to find the scale factor. So the first thing I really need to do is I need to go through and figure out which one my new one is. New is always wherever the primes are. So all of our primes are right here, so the one on the right for us is going to be our new one. That first part, it wants to know the scale factor between the side lengths. So I've got to use proportional side lengths. So on this first one, I can use either 10 and 5 or 6 and 3. If I did 10 divided by 5, or if I did 6 divided by 3, either way, I get the same exact number. Either way, my scale factor here is going to be 2. Now it says, what is the scale factor between the perimeters? So I have to go find the perimeters. So I'm going to take a look at the big one first. My perimeter is just all of the sides added up. So if I add the 10, the 10, the 6, and the 6, I get 32. Now I have to do the same thing on the small one. So I'm going to add all my sides. So I've got 5, 5, 3, and 3. So I have a perimeter of 16. So I'm going to take those two perimeters and I'm going to divide them. I'm going to do 32 divided by 16. So 32 divided by 16. And either way, I get 2. So what I tried to make as clear as I can when we were in class, and I want to say it here too, whenever we're talking about side length scale factors and perimeter scale factors, these are the same thing. If I know a side length scale factor, I know a perimeter scale factor. But now I've got to do this with the areas. So now I've got to go back and find the areas. So the area for this, area of a rectangle is just length times width. So I'm going to do 10 times 6 and get 60. Over here in the small one, I'm going to do 5 times 3, and I'm going to get an area of 15. So this time around, I'm doing 60 divided by 15. So I'm going to do 60 divided by 15, and I get 4. There is a relationship between the side length scale factors and the area scale factors, but I'm going to talk more about that on the next one because I think it's a little bit easier to see. So here on number 2, we're going to do the exact same thing. We're going to do new divided by old. And I'm not sure why I did that little 7 over there in red. That's supposed to be in blue, but some of you guys probably already figured that out. So I'm going to do new divided by old. This time I'm going to do 28 divided by 8. 28 divided by 8. When I divide these two, I get a scale factor of 3.5. Because of what we did before, we know my scale factor for the perimeter is also going to be 3.5. But I'm going to still show that to you guys anyways, just to be on the safe side. So my perimeter for my original one, I do 8 plus 8 plus 2 plus 2, and I get 20. And on the large one, I'm going to do 28 plus 28 plus 7 plus 7, and I get 70. With these two scale factors, or two perimeters, I'm going to do 70 divided by 20. And when I do 70 divided by 20, I still get 3.5. Now, for the area, I've got to find the areas again. Area of the small one is going to be 8 times 2, and I get 16. Area of the big one, I'm going to do 28 times 7, and I get 196. So I'm going to take my 196, I'm going to divide it by that 16. When I divide these two, I get 12.25. Now, the relationship between these two, between the side length perimeters scale factors and the area scale factors, whenever we're talking about area scale factor, it's actually the same thing as the side length scale factor, but squared. So that would be 3.5 times 3.5 would give me the 12.25, just so you guys are aware of that. It makes for a nice quick shortcut sometimes if you're trying to work through them fast. Pretty much on the rest of those, I'm going to let you handle them, but I do want to hit a couple others. Here are the numbers for the backside for whoever needed it. But again, it's going to be kind of the same thing as before. You're going to you do new divided by old for each part, so you guys can come up with the scale factors. Some of these won't be too hard to see. For this backside, on number 7, it says an architect was hired to construct a den in the shape of a square. If the client wanted to double the length of each side of the square, what would the scale factor be between the side length, and what would the scale factor between the areas be? It says that we're going to double the length. So doubling the side length, my scale factor, or K if we want to call it that, is going to be 2. Well, K for the areas, we talked about it before, is going to be 2 squared. So our area scale factor would be 4. And I know they didn't really give us any numbers to work with outside of that word double, but you can always make up your own side lengths for a square and then try doubling them and see what areas you come up with. I'm going to do one more just to help you out a little bit more. Then we're going to take a look at we'll do number 11. It says an architect was hired, it's the exact same problem. I'm not sure why I'm reading it again, but this time they're going to scale it down by a third. So my scale factor for the side lengths is going to be 1/3. The scale factor for the area is going to be 1/3 squared, which is the same thing as 1/3 times 1/3, and that's 1/9. If you have any questions on this, guys, come to tutorials so I can help you out on it.